Welcome everybody. For those of you joining live, thank you as always for being part of the DevLake community. And for all of you tuning in on the recording, thank you as always for being part of our Slack community. Thanks for joining us on YouTube and diving deep into the lake with us. So today I've got a good friend of mine, a good new friend. This gentleman I'll be speaking with today, I met recently at the Apache conference in New Orleans. James is a member of the team over at Red Hat, and him and I connected on a variety of different levels, shared interests in some things in our personal lives, from especially wristwatches, and we have, importantly for today's discussion, a big shared interest in what the role of data really looks like and how we solve many of these challenges associated with it in engineering and in open source, from kind of visualization layers to analysis layers to kind of processing and storage layers. There's so much to it. And we had an opportunity, of course, to dive in deep together and kind of talk about many of our kind of shared perspectives and goals. And I think today's discussion is going to be really quite interesting as a result. It's a great example of where the open source community can really come together to help each other mutually and to drive things forward. So first off, thanks, James, for joining me today. Really appreciate you taking the time to sit on this recording and have a conversation. I've always enjoyed our chats. So perhaps before we dive into our conversation, would love to kind of get an informal, introduction from your end. What are you doing these days, and how did you get into this line of work that you find yourself in?
Thank you so much, Maxim. First of all, I am going to make a brief note. I so appreciate the picture that you put up of me. That's from my LinkedIn. The context is a giant plush dinosaur about 4 feet tall. So my neck isn't usually that strained. But to answer your question, so I work at Red Hat in the open source program office. And my colleagues, who are mostly community managers, are tasked with being Red Hat's envoy, I suppose one could say, of community stewardship, managing communities that Red Hat has a strategic interest in. We have Fedora, and I know we've had Overt, and we have OpenShift community managers, even though that's our downstream. And because I'm in that environment where we're asked with caring super, super deeply about open source projects, and because we live in 2022, and the word that everybody is thinking of in tech is big data and stuff, I work as a bit of a cross-functional investigator, joining community stewardship that my colleagues have brilliantly done with their expertise and intuition, with a data science component. And that has been facilitated by the unbelievable work coming from the Chaos Foundation's Augur project, collecting community data. So to summarize into one chunk, I work in the open source program office, and I'm working with a small team to find a way to join community management with data science. I came to this job right out of college. It was my second opportunity with Red Hat. I started out in the build compose process in engineering, which is the process by which packages are included with an operating system before testing. And I just fell in love with, I want to be very specific. I fell in love with the process by which we bring data that we mature data into a fully realized part of our intuition. That's fluffy to say, but I care deeply about the gap between just looking at the data and doing brief summaries of it and connecting the level of connecting it to our intuition and being responsible for the data, making sure to communicate to consumers that the data is never perfect. The data is not an oracle. The observations made from the data aren't perfect facts, but I care deeply about that neck of the woods in the tech ecosystem.
I love that. No, and I think you touched upon a key part of this, right? Which is, being able to kind of tell some of these stories with data, being able to support your intuition with facts and with more quantitative measures. Because I think that's perhaps one of the misconceptions that people have, right? Is they think, oh, you're handing me analytics, you're giving me this kind of quantitative approach, and you're saying that this is a replacement for my own kind of understanding or my own gut instinct or my own instincts and intuition. Where I think it's perhaps more accurate and fair to say, like, no, it's not doing any of those things. It's augmenting all of that, and it's providing you with even more basis to focus on the correct things when it comes to that kind of like qualitative kind of finger in the air, gut instinct. It's supporting that by removing all of the static around it. And I'm curious, James, from your kind of perspective, one of the questions we talked about, and it's certainly a big one, is kind of how you think about, the role of data in kind of assessing engineering at large, right? There's so many angles that we can take with this. And it sounds like a big part of what you're thinking about these days is kind of assessing, ecosystems, assessing communities, assessing kind of the health of a project. But as you kind of think about that, I guess to start, how do you think about kind of the role of data in kind of decision making or strategy, and what kind of things are you focused on as far as kind of the outcomes, whether it is kind of health or kind of speed or quality or whatever it is? Would love to kind of hear about how you conceptualize it on those levels.
That's a phenomenal question. And I think your question dives purposefully deeper than what it touches on. I'm always a little bit wary of with presenting data to anybody. If someone comes with a good statistical background of any kind, experimental statistics from undergrad social science classes, they will have the reflex that any data presented to them is just that. It's observations. It's a local population in a global population world. And it's the job of someone who works with data to steward that interpretation, to make sure to communicate that any intuition derived from these data points is just that. It's local. It's not an explanation for the entire environment in which the data are pulled from. And speaking in terms of your question, what is the role of data in engineering and in specifically our work in project management? The work that my colleagues have been doing, community managers, is based on unbelievable expertise, intuition, interpersonal relationships, none of which can be quantified by the data. There will likely never be any model that can replace that expertise. They are unbelievably brilliant people. The hope is that the work that we are doing will, like you say, supplement that, give a bit of a check against, I don't even want to say against, supply these people with the ability to see from a higher elevation momentarily. They can see a local cluster of what's going on, see if their intuition is on point, but we don't want to remove that ever, the intuition, from the whole equation. And I think sometimes data has more intrinsic power than what we're hoping to wield it with. but that would be how I view data in these systems. I don't believe in using data purely for, in different contexts, engineering productivity. I think that that's a tiny sliver of the picture. I don't believe it in using data, and I'm saying purely as like the only metric. You've seen, most people have seen ethics questions raised about recidivism rates with prisons and models that predict whether or not someone will commit another crime. Like that's a terrible use of a model of any kind. So extrapolating that to engineering in general, I think data has to be treated with respect. It is not an oracle, but it's important to use it to bolster intuition where possible. And that's how we're using it on our team.
Yeah, no, that's really well said. And I think, I think that's always the kind of critical piece of the puzzle, right? Is understanding that data analytics systems, visualization systems, it's the tool, right? And it's not like you can just put a hammer on the desk and expect it to drive in the nail. You also need the understanding to be able to use that hammer to put the nail in. And I think it's, if the analytics systems are the hammer, it's the intuition that is the arm. It's the two working in concert that's going to accomplish the end goal. And I love the way you kind of phrased that. It's being able to kind of see things from a higher elevation. And I think that's surely where, kind of a big part of the value is, right? Is being able to kind of understand, like, okay, what am I seeing directly in front of my face? Is this kind of a pattern or a trend or a behavior that I can also see, from a more macro level, be it, on a team-wide level, be it on a company-wide level, or maybe even on an ecosystem-wide level, right? And being able to translate that kind of one-to-one understanding and encounter into kind of a bigger picture insight can be so valuable. So, I think something that this touches on, is another part of, what we discussed in some of our conversations. I think there obviously like many applications, of data and many use cases. And I think one of the big challenges that people have is figuring out like where do I even begin, right? This can be an overwhelming process, and perhaps this is one that you've seen and encountered for yourself on a few occasions. Someone's like, okay, I buy in. I think data can be useful. I think analytics and insights are going to be exciting. But where do I begin? Like, people get stuck there, I think. So I'm curious, when you think about kind of beginning, a data strategy and beginning kind of your journey in assessing something like this, what kind of things come to mind for you as far as kind of making the right decisions, approaching it the right way, coming up with a strategy of saying, okay, let's deploy data here, let's assess it, let's analyze it, let's visualize it. What kind of guidance would you give to, say a engineering leader or engineering manager or anyone, right, who's just looking to get those insights and translate them into something helpful?
That is an excellent question. And thankfully, I have an excellent colleague. Her name is Callie Dolphy. She's a data scientist at Red Hat. And her talk that she's given at, I believe she gave it at Scale. She gave it at DevConf US. And I think she might have given it at ODSC East. I don't remember that. I'm sure I'm missing conferences that she's given it at. But she gives an excellent framework for just this question. So let's make a couple of assumptions. Let's say a team has some amount of data, and that team wants to find some way to use that data to enhance their process, to make clear what is a little fuzzy intuitively, or to see things from a higher level, from a higher elevation. Callie puts the framework like this. Let's say that you had infinite engineering resources. What would be the question you want answered. Are my engineers being productive? That's a question one could ask. Is time being well spent? What are our stakeholders happy? Those are really big questions that aren't easily answerable. But intuitively, you start to break that question down. Let's take the just an example. Are my engineers being productive? Well, what constitutes an engineer? Are you including your DevOps people, your SREs? Are you including people who work in documentation? Subdefine everything that's important about that first part of the question. Are they being productive? Well, what is productive? Is productive volume? Is it quality? Is it the fewness of tests failing? Is it in a team, productivity could be the fewness of events if you're a maintenance team. So now you've dug a little deeper. You're saying, okay, are people who are working with technology on our team making it possible for, let's just take that last example, fewer firefight events to happen? So now you've drilled down a little further and you say, okay, can we interface this with the data we have? And maybe you do a little fundamental data exploration with something that makes it easy, like Tableau is ridiculously powerful. Superset, great. Like unbelievable tools. Maybe you're in the Python ecosystem and you do a little looking around and see that, okay, we have some columns that join our developer base with instances of events we are interested in either maximizing or minimizing. And now you have a better handle on where you could find that data consolidation portion. So as Callie would say, you start with the ultimate, what you want, and then you drill down on definitions. You say, okay, who are the players? What are the events I'm looking at? And what am I trying to minimize or maximize? And if all you have in the beginning is that drive to answer a question and the data to support it, you're on the right track if you follow that framework. The key is, do you have the data? Maybe you find the question in hand cannot be answered with the data. That is an incredibly powerful question to have answered. I can't do it with the data I have. Maybe the data will never exist. Then it's not a data answerable question. And that is as valuable as having an analytical model, in my opinion. So I hope that answers the question well. That's how we go about it in our work.
Yeah, I really love that framework that you laid out and kind of the approach there of thinking, first of all, right, like what's a future that you envision or a goal that you have that you want to accomplish, and you point out some great examples, right, where you have to have kind of that endpoint in mind to figure out where you're going to make the maneuvers, and how you're going to use those insights, and I love that idea, right, which kind of drilling down to like, okay, do we want to improve code quality? Do we want to, improve productivity? Do we want to improve velocity, or do we want to improve community health? And what does that mean, right? Because it's going to vary by organization, by team, even by individual, right, in terms of how they're thinking about what that means in the context of their perspectives and their opinions, as well as their organizational goals. So I think that's a really key and underestimated piece, right, is being able to kind of coherently define and agree upon what all of that means, and then starting to figure out like, okay, what data points are going to be helpful there, and what's going to kind of empower us to answer that question. And do we have that? Like, are we going to be able to actually draw good conclusions? And I like the example you brought up, right, about, like, are developers happy, right? Like, you're surely not going to figure that out from Jira tickets, or maybe you would, but it's a critical piece of the puzzle is kind of mapping this out, and certainly something that I myself has seen, is kind of a key difference maker in, a successful outcome versus kind of a ho-hum outcome, with analytics and anything, right? Is like, do you already have a goal in mind, right? Because if you're just saying, let's apply data to this big undefined problem, right? It's like, great, you're just going to have a whole bunch of numbers that probably just stress you out and overwhelm you and gonna do nothing, right? But if you're taking that perspective of figuring out like, okay, well, we want to solve this, like we want to get better at that, like that's where the magic really truly happens. And this kind of segues nicely, James, into another kind of question I was excited to get your perspectives on, which is kind of common misconceptions, right? I think we've covered a few of them and touched upon them, but I'd love to kind of linger on that topic a bit and go a bit deeper. When it comes to kind of the role of data or data science in general, or kind of setting up analytics systems to answer these kinds of questions, what are some of the kind of misconceptions that you kind of commonly encounter that people have when they kind of think about what all this actually is or means?
That is an awesome question. And it has a couple of very short answers that I've kind of already nudged toward. But I would say, first of all, there's an assumption that most people go into holding, which is that the data is arbitrarily correct. You might have, your data set might actually be a population level data set, in which case you can treat it with a bit more, latitude about your conclusions. If you have all of the data about some relatively closed system, you can make some more practical generalizations. But the data are singular. What's the specific word for this? They're discrete data points in a continuous space of describing any system. And so the in and out is, people think that data is correct because it's been collected and they trust whoever collected the data, and then they work with it as though it is correct. And they make assumptions about the system that the data explores based on that correctness assumption. And I would say that to a certain head in the right direction. There's a famous saying in data science and in machine learning, which is all models are wrong and some are useful. And I think that is a necessary perspective to go in with when you're working with data. You have to treat it as a first-class citizen in your software engineering process. It can't just be, they say data is the new oil. Data is a big bag of gold and fool's gold, all mingled together as tiny little fragments. Some are right, some are wrong, and you have to have a specific process to make sure that you're elucidating those correct ones. I had another misconception that I thought was integral. Oh, yeah. If you have a model that's been trained and it's 90% correct, 99% correct, that is a local model, like I've said. And so it can be really useful. If you have a machine learning process and it's very accurate, that's good. But that doesn't respond necessarily, unless very well engineered, well to outliers. It doesn't capture every individual. It's still a discrete model in a continuous case. Your categories can be too narrow. And so I would say, to wrap up the question, take data as it is, which is just observations that try to capture some continuous behavior in a discrete way that is collected with human bias and engineered with human bias, but that it can be useful if treated as like with a little bit of concern, like, I don't know if I'm gonna, I'm not gonna put this person's bonus as connected to their, machine learning model performance. That's ridiculous. It can't work all the time, and it shouldn't impact someone if it's not going to be perfect, and no model's perfect. Those are the major misconceptions. I'd say that data is correct and that models, very high accuracy models, can be trusted across the board. Those are two good touchstones, I think.
Yeah.
What do you think?
Yeah, those are excellent points for sure. And I think that idea, right, that the more there's probably some kind of parallel to, right, the Heisenberg uncertainty principle, where it's like, the closer you look, the more you're going to influence the system. And I think in kind of a semi-parallel way, right, you kind of have this paradox where it's like the more locally accurate you are, the more globally inaccurate you risk being, right? And I think that's a really great point to consider. And I certainly think, the underlying emphasis on, thinking carefully and critically about, like, how good is this data? Like, what's the kind of potential flaws that it might have? What are the kind of potential kind of kind of pollutants or kind of biasing factors we could have in this, right? And we've surely encountered that, in our journey analyzing code and analyzing engineering processes, as I'm sure you have, right? Where in some cases it's something simple, right, where you've just got to exclude a gigantic open source focused commit to be able to get a better sense of, like, okay, what are the team actually writing and delivering themselves, right? Because if you're indiscriminately just assuming everything is good, then you're going to start saying, James is the author of the entire React framework. Pretty impressive, and that's obviously a very ham-fisted example, but one that kind of, I think, captures that essence, right? That if you're taking that kind of either naive or kind of blindly trusting approach to the underlying data source and information, you can certainly send yourself astray. So something you and I have talked about, which I thought was quite an interesting concept of yours, is the idea of kind of minimum viable engineering footprint, and the concept of minimum viable product from a kind of analytics perspective and from a kind of data examination and analysis perspective. I'd love to kind of just toss that over to you, James, and have you kind of describe to our listeners, like, more of, like, what that means as you kind of think about that question of, like, what's a minimum viable product in the context of data analysis or analytic systems, and minimum viable engineering footprint sounds pretty cool. What's that? Would love to kind of get your thoughts on all of this.
Absolutely. Well, I think I'll touch on minimum viable engineering footprint first. This comes as a bit of a survival instinct because we are a very small team. Our little team is 2 people working really hard on this, with a number of brilliant people who are working on coterminous projects. And so when we were deciding which technologies and tools we were going to use, we knew we weren't going to have dedicated DevOps professionals or site reliability professionals, dedicated data engineers or data scientists besides ourselves. And so we started with a good understanding of what we wanted to show at the end. We wanted to show specific metrics, single numbers or combination of just numbers on a page. We wanted to show figures describing time series data. And we wanted a good degree of user responsiveness and enjoyment, and an ability to delight the user via customization and aesthetic tuning. So we came in knowing those things, but we knew that with so few people, we had to be sure not to stretch ourselves too thin. And so I'm going to use that little case study to describe a process that a team, maybe who has data and knows that they want to show something about that data, might go through in order to present it well. The order that we went through is, okay, can we do this in superset? Superset is phenomenal. We found that superset would be a really great choice, but it didn't quite meet some of our needs of a Python native ecosystem, because we knew we were going to be running models on the fly. Did Grafana work for us? Well, Grafana almost worked perfectly for us. But again, it was that Python native ecosystem. We did a deep dive on Grafana, and it would have worked beautifully with the database that we had, but we wanted a little bit more control, and we knew that we wanted to dog food some Red Hat deployment products. So we decided to go that next level up, which is an abstracted away Flask instance, essentially, Flask application. And that served us relatively well. It's called Dash, and I give a talk about it, gave it at Apache Con, which is where Maxim and I met. And Dash is a very convenient tool to use. It has a great community. But let's say that it didn't satisfy the needs that we had. Maybe we do have really excellent web devs, even one or two more, that can actually take advantage of a bit more of a corporate level, production level deployment. Then they might go for a full Flask kit or a JavaScript native framework. The point of this whole story is it is important to balance what you can provide with how much time you have to provide it. If you're spending hours and hours and hours of engineering person hours on getting some framework to work that you know will solve your problem but is too heavy weight, that's a huge waste of your expertise, one's expertise. Maybe Grafana solves every problem and you don't need to go towards a Python native thing, or maybe Superset or Tableau solves it because you do periodic dashboards. That's awesome. Those are amazing tools, and they don't require the same kind of SRE DevOps overhead that we've incurred by choosing to use a Python native thing. Now we're working on a complete data backend update with an online analytical processing database to serve our stakeholders a lot faster. And that's not something we would have to consider as dramatically if we had the ability to pick a lower overhead tool. So the punchline is you can show a lot of awesome things in a lot of different technology stacks. But if you're spending a ton of time maintaining it, that's counter to the amazing work you can do cracking open the data. And I would encourage people, engineers, as they go through the process of trying to serve that data, to really be aware of, okay, is there a compromise I can make on what I show such that I show as much as I can and I make it easy to maintain it. I don't drive myself into technical debt. I don't make it impossible for me to maintain with all the YAML files. I don't have enough time to deal with it. And if you can do that, you're on the path to a much more pleasant and quickly iterating product, I think. That's how I would frame it in a nutshell.
Yeah, I think that's a really good point for people to consider, of course, is, what's going to be realistic for you to reliably manage and service and integrate into your process, right? Because I think much like a good diet or a good workout regimen, right? A good data practice is not something that you're doing once a quarter and then expecting yourself to be a Olympic triathlete, right? It's like it's the accumulation of a consistent practice that yields that outcome. And I think you obviously can't do that without first starting with something that you can actually properly manage. And I love that, I love that kind of simple truth, right? And it speaks very nicely, I think, to a big part of what drove us to create DevLake in the first place was something that was going to, of course, have some engineering overhead, right? You're never going to be able to have anything this customizable and kind of this flexible without some overhead, no doubt. But we did want to kind of create something that aside was going to present all of that capability of, hey, once you've got this set up, you can manage it, you can own it, you can customize it, and it's not going to take a lot of your time and attention. Because the bigger point that you take, right, is which I think is critical, is just make sure that ROI is there, right? If you're spending 6 hours of energy to ultimately obtain an outcome that saves you 1 hour of resources, well, that's a big net negative, right? You want to be able to find those opportunities where you've said, okay, we've committed 10 hours of work to doing this thing, and now across the year that's saving us 200 hours of headaches and effort, and that's exciting, right? Like that's a 20x return. So I think that's a important important consideration to make in these equations, no doubt. And I'm curious, James, if we kind of take a theoretical, I'd be interested and perhaps this will kind of capture a lot of what we've already discussed in some ways, but I'd love to kind of step into kind of a theoretical quasi role play, if you will, of if I was kind of a engineering leader, or maybe an open source leader or an open source maintainer, and I came to you and I was like, hey, I want to figure out if my project or my company is healthy, or if it's succeeding. And we're grabbing coffee. What are the things you would kind of guide me towards thinking about, and the kind of stumbling blocks or strategies that you would want me to consider to make sure I ultimately succeed? What are the things that come to mind for you?
Open source software has an almost inarticulably valuable resource, and that is intelligent criticism. And that has led to the establishment of really good guidelines for definitions. If you want to say publicly that your work is showing something, you want to be able to point back and say, this is where I got this definition. So you ask, what's the first step to having something that's like, okay, is my community healthy? The first thing I'd tell you to do is go try to find some living document that defines health, that defines community, and have a really good handle on what you actually want to show. And a good example of that is the Chaos Foundation. They have a 200-page plus guidebook that describes these these metrics. What is health? What should it show? And once you have that in hand, I'd say, okay, what data do you have? How easily can you come up with more? Is it trustworthy? We feel super good about our data because we're working with the team directly that collects and engineers it. But if a team is grabbing data arbitrarily from a source that they don't necessarily trust, I'd say be wary of that and set your sights more very reasonably based on the trustworthiness of the data. And so I'd say combine those two things. Say, I have a definition for what I want to show. I know that I can trust my data, and this isn't the best case. Now let's see if the data is thorough enough to support something interesting. If you have 50 rows, you're probably not going to be able to show anything good. It's highly local. If it's not longitudinal, if it's not over a long time, it's not very good. So what's your data quality? And once you get to there, it's a tooling question. Maybe you want to look at it first in Tableau, because Tableau is really useful for that kind of thing. See if you can construct naive visualizations that describe something. And maybe that's a smaller part of the metric that Chaos Foundation defined, or wherever you got your definition. but it's a step in the right direction. You can collect those metrics into a greater summary metric. And with those things all in hand in this best case scenario, I think that it's relatively intuitive to go to that next step. But the critical step following, maybe that synthesis step towards your ultimate goal, is now you have a responsibility to iterate, to get feedback, to hear what people think, especially the best critics in open source software, because people are really good at that. Check in with community, check in with people who want to flame whatever you've made and tear it apart, because those are the most valuable people in these situations. And once you have a semblance that you've appeased them to the level that you need to, you've answered the question you care about, you feel good about your data, then you can start seeing what stakeholders think. Does this jive with what they think is useful? Obviously, it's good if they have a buy-in in the beginning, but once you have a product, does it sound right? Does it pass the sniff test? And then I think you're just iterating, trying to make it as good as possible.
Yeah,
that's how I go about it.
Yeah, I think that's really key, and I think the interesting insight there, for our community as they kind of think through these kinds of challenges, right? Is you'll notice that James is somebody who's got a pretty world-class grasp as far as understanding the ecosystem is concerned, right? Many different products and technologies that he's mentioned by name and talked about, but also what you'll notice in many of his answers is it's rare that he's talking about something that's like product or technology specific to solve the problem. And instead, the focus is very much on that kind of like front end work of figuring out like definitions, figuring out goals, and coming to kind of coherent structuring and definition of those things to then be able to take those tools and put them into practice. And I think that's a really great kind of takeaway for anyone that's listening to this, right? To be able to recognize that that's where they have to begin. And it's that kind of strategic work that informs the kind of the next steps and the ultimate success of any kind of analytics driven process.
I agree with that. It's if you're not, I'm just going to borrow, I want to add a little thing to that. It's like mathematics. You start with your axiomatic reasoning and you build theorems from axioms. And if you don't have the solid groundwork, you're not preparing yourself for success. That's how I interpret that. Yeah.
Yeah, I think that's really well said. It's that kind of groundwork that's going to determine whether or not you do succeed or not. So I love that. I love that point. So James, to kind of circle all the way back to the beginning, something that I was curious to kind of get your thoughts on and hear a bit more about your personal story. What brought you to Red Hat? We obviously kind of dived deep straight away, which is I think a big part of how you and I kind of connected so properly straight away was like we wasted no time kind of getting into the weeds on our personal interests as well as our kind of professional goals. But circling all the way back, your kind of career is interesting to me, at least in the sense that you kind of started straight away in many ways in a kind of an open source centric universe. What was that journey like, and what got you there, and what's life like at an organization like Red Hat that plays such a prominent role in the open source ecosystem?
Life is good. Working at Red Hat is a pleasure. My direct chain of command are really excellent professionals. They're phenomenal to work with. The leadership at Red Hat makes me feel like I'm a part of something that's driving towards a very mutually agreed upon goal. I like that the way that Red Hat makes money is copacetic with open source philosophy. And that's mostly where I connect with Red Hat. Excuse me, where I connect with Red Hat. I wanted to work at Red Hat because I care really deeply about getting to go to work and feeling like I'm doing something that is useful across the board. I'm not a very militant open source person. I believe that there is a role for proprietary software. There has to be. Secret sauce in companies is, a fact of life. But I really love working at a company where I can have a conversation with Maxim about exactly what I'm working on, and we can come to a conclusion in an hour that there is an overlap and that there's no brittle competitiveness. When I finished, I finished my undergrad and my master's. I had been working as a researcher for Red Hat, and that was in machine learning. And then I was working in the engineering side and operating systems stuff with the build compose team. And after my master's, which was in mostly machine learning, named computer science, but I was aiming mostly for machine learning stuff. I needed to be in something that was heady and like aggressively modern and doing something no one had seen before. And I really wanted to work in open source community work because it was so interesting. Like, these are evolving and brilliant groups of people who work together to create something that everybody can use, and that they're fiercely intelligent, but they're not ultra competitive across projects, at least. I mean, that can absolutely happen. That's natural. But that was why I wanted to work at Red Hat and why I wanted to work with OSPO. My peers are amazing. The work I get to do is amazing. It jives a lot with what I like to do as a professional and from my academic background. And lecturing at BU, I was briefly a student lecturer. All I wanted to talk about was open source stuff. It made sense. It clicked with how nice you can be to people and also develop software and make money. So that's how I would put my relationship with Red Hat. It's a really copacetic relationship between an ethical way to develop software with brilliant people right at the cutting edge, and with the freedom to openly discuss projects and to get input that doesn't feel cutthroat. That's how I feel about it.
Yeah, I think that's really well said. And that was, of course, a huge part of what made it so exciting for you and I to connect, was this realization of like, oh, we're both thinking about many of the same challenges, and we're both focused on different parts of solving that challenge and coming together to figure out, okay, like how can we explore that 1 + 1 = 3 outcome, right? And as kind of silly as that sounds, I think that's a big part of how I personally, conceptualize open source in general, right? Is it's that pursuit of 1 + 1 = 3, where you're saying, okay, we can combine resources, whether it's energy, perspective, time, contribution, and build something that is greater, than the sum of its parts. So I think that's really well said. And to kind of wrap up, because I know we're closing in on time here, and this has been a great conversation, as I expected. I'm curious, James, for your kind of advice to someone who is maybe kind of looking to kind of follow in your footsteps, maybe someone who's on the beginning steps of their academic or professional career, and they're interested to dive into data, maybe interested to dive into machine learning, or perhaps open source, or maybe the intersection of all three. What advice would you give that person, or what advice would you give your younger self as you were kind of embarking on on this endeavor?
It's really tough to make a blanket recommendation, but so I was pathologically lazy as a kid. I built my first computer when I was 14 because I wanted to play video games on it and learn how to render CAD stuff. It's actually this machine here. But I didn't feel like I had the drive to go learn how to code or learn machine learning stuff. And I'm going to address those people because that would be who I would. This advice would apply all the way up, but the roughest advice is just go start. Just go do something. Do anything. With open source, everybody's contribution is necessary. Updating documentation, adding aesthetic touches to projects, readmes, tightening stuff up, all the way to major code contributions. All of it is needed to succeed. For machine learning and data science stuff, if you have a little bit of math background, you can go really far with it. The most advanced math that I do regularly, I mean, not anymore professionally, but in academia, was like vector and matrix calculus and linear algebra stuff, which is challenging at that level, but the barrier to entry isn't so high that you couldn't learn some of the fundamental stuff relatively quickly and get going. But that's not even where I would say to start. I would say just go follow any tutorial to get any model working. It's amazingly simple with these amazing new APIs. I say new. Keras and PyTorch are the ones I use the most. My cat's yelling. And I'd say just go do it. Get your hands dirty. Have fun. Learn some technologies. Get a little good with the shell, with the terminal. Mess around. Have fun. And you'll find that if it's something that really speaks to you, you just won't want to put it down. And then there's all these tools you can learn. Learning cloud native deployment and model building and serving has been a blast. Hello. Come on, bud. And I just say, if it's a passion that really sticks with you, launch headfirst into it. There's an awesome book called Pragmatic AI. Forget the author. And that's a good starting point as well. That was pretty much the summary of what I told my students in the class that I lectured for. You just gotta dive in because no one's gonna give you the perfect walled off playpen to get you started on everything you need to. And I'm teaching 5 people data science right now as a side gig. These are just my friends. And that's where I say to start, go get your hands dirty and have fun. And if it's something that appeals to you and you love it, you'll find the next few steps.
Yeah, I think that's
how I feel.
That's really well said. And that the book you recommended, Pragmatic AI, I'll make sure to text you to get the correct one, and
I have it,
and I'll post it in the Slack, and I'll put it in the YouTube bio as a link for people as well. And I love
Noah Gift.
There we go. Noah Gift, the Pragmatic AI. I'll be buying myself a copy for sure.
This is cool.
And I love that point you made, right? Which I think is something we get so excited about when we see people, getting their hands dirty with analytics and visualization and everything we've discussed with DevLake, right? Is that kind of fundamental truth that you point to, which is at the end of the day, you can read as many books as you want on swimming, and you can watch as many talented swimmers jump in the pool as you want. But until you actually get in the water yourself and start kind of struggling and figuring out how to keep your head above water and propel yourself forward, you're never going to be able to bridge that gap from theory, to implementation. And I think that's in some ways the beauty of open source in a nutshell, right? Is it gives you that opportunity to dive into any pool that you want and learn any technique that you want. Ideally with the support and collaboration of a world-class community, which is
Absolutely.
what we're so excited to be building for ourselves. Well, James, I know we had to change our schedule on account of an important meeting you have, so I'll be mindful of our time here. But as always, I'm so grateful that you and I met at ApacheCon. So glad to call you a friend and a collaborator, and I'm excited to see all of the things we can accomplish together when it comes to this big picture challenge of applying data in a better, more effective way to engineering and open source. So thanks so much for your time today. I'm really glad we were able to make this happen.
Maxim, and to the entire Apache DevLake community, it is a pleasure and a privilege to get to be a little part of this community. Thank you so much for making the time and letting me be a part of this. It is really a pleasure. I hope this was valuable.